Okay, now so we have completed mutation. Just like there is another systematic force which will affect our genotypic frequency. So in hereditary mechanism in groups, we assume each group has its own fixed gene frequency, and this gene frequency may be changed by the migration. So what is the meaning of basic meaning of migration? That some gene will transfer to one gene pool to another gene pool. Okay, some gene will transfer from one gene pool to, suppose this is gene pool 1 and this is gene pool 2. So few genes will transfer or migrate it from one gene pool to another gene pool. So this the effect of migration on the frequency of an allele in a recipient population. Suppose this is a recipient population, and suppose and this is donor population. So some genes will transfer from the donor population to the recipient population, or vice versa. It can be from both the side also. So this recipient population depend on the rates of immigration, and there is another term, emigration. So these two terminologies are important. Whenever you go means by flight, by air, through air, so there is one immigration certificates. Like immigration is also there. So this is the frequency that moving out from the population, moving out from the population. It is known as emigrants, emigration, moving out from the population. And what is immigration? This is moving into the population. So if we see here, from this, some if some genes are there that is transferred from one gene pool to another gene pool. So this is what moving out for this gene pool 1. This is moving out from the population. Okay, so this is immigration for gene pool 1, and we can say moving into the population, that is immigration for gene pool 1, immigration for gene pool 2, and emigration for gene pool 1. So suppose if I take this, like suppose this is my population and this is donor population, and this is recipient population. Now proportion of M genes, suppose proportion, this is proportion of M genes are there which are transformed from donor population to the recipient population. So this is, and so this is what moving out from this population, and moving out is known as emigration, emigration for donor population. Okay, and moving into the recipient population, so this will be known as immigration to the recipient population. Okay, so suppose now this is natives and immigrants. Suppose our earlier gene frequency, suppose this is I am taking as a native population or recipient population. So this is known as natives, and its earlier frequency is Q0, and after immigration it's this is QD. means QD proportion of genes will transfer from here to here. Now, and this is relative immigration rate, that is known as 1 minus m and m proportion. So m proportion of QD genes is going from donor population to the recipient population. So I can say that after immigration, the gene frequency is Q1. Earlier it was Q0. Now after immigration, the gene frequency is Q0 into 1 minus m. See here, Q0 into 1 minus m plus QD into m. So I can solve it and we will remain with that Q1 is equal to Q0 minus m Q0 minus QD. Q0 is initial gene frequency and QD is after immigration. So if I calculate delta Q, this will be Q1 minus Q0. So Q0, this Q0 will be cancel out and this will be minus m Q0 minus QD. Okay, you remember this. This is important. Delta Q. Okay, so this is important, that what is the change in gene frequency after migration. Now I can say that delta Q is directly proportional to m. This is immigration rate, means by which rate the genes are migrated, or it is directly proportional to the difference in the gene frequency. Earlier gene frequency to the, this is difference and this is immigration rate. So likewise, after we can calculate like Q1 minus QD after one generation, two generation, three generation. So after n generation, if I directly write after nth generation for calculating the generation n, that we can calculate like m is equal to 1 minus, this is important formula, 1 minus Qn minus Qd upon Q0 minus Qd. So remember this formula, to the power 1 by n. So this ratio is used to estimate the proportion of genes in migrants. This is used to estimate, I will tell you one example, the proportion of genes that is migrated. So this is important. Okay, so now we will see one question regarding this. So question is, initial gene frequency is given like 0.02, then it is given that QD means, what is QD? What is QD? After immigration, the gene frequency of the recessive allele. So this is given as 0.43 and Qn is also given, that is 0.094. So there is means there is a statement of the question and I have found this all the three events, that migration model is there, allelic frequency found in. So there are two population, that black population, black and Cauc- Caucasians population in US, and Negroes are currently living in West Africa. West Africa. So US Caucasians जो frequency है that is given as 0.43, that is after migration. It is a very lengthy statement of the question. After reading the question you can easily calculate, find out that this is the initial frequency of the population, this is QD, means that after migration, and this is after nth generation. Now, this it is given that frequency of black people in Auckland after means migrations after nth generation. This is given as 0.094. Now, if I want to calculate the proportion, that which proportion of gene has been transferred, so I told you this particular this ratio, it is useful. So this type of question can come in the exam, that the ratio is Qn minus Qd divided by Q naught minus Qd. So what we are doing here, nth generation gene frequency minus after migration gene frequency divided by initial gene frequency minus same after migration frequency. Okay, so Qn is given as 0.094 minus QD is given as 0.43 divided by Q0 is given as 0.02 minus 0.43. So we can calculate here 0.336 divided by 0.41. So after calculating, I'll get 0.82. So what is the what is the means this interpretation of this 0.82, that 82% of genes were of West Africans. 82% of genes were West Africans, and remaining 18% of genes were Caucasians. Okay, so this we have checked that which proportion of which genes is having the population. 82% is there of West Africans and 18% of genes is having Caucasians. Now it is given that of n is equal to 10, that 10 generation, after 10 generation, what will be the rate of migration? Okay, so our question is to find m. N is given, that is n is 10. So what is the rate of migration? 1 minus m to the power. And what is the formula of this? See, this is the formula. M is equal to 1 minus Qn minus this. So what is m is equal to m is equal to 1 minus q n minus qd upon q0 minus qd to the power 1 by n. So if I take this side, so this I'll get 1 minus m is equal to qn minus qd upon q0 minus qd, and this is 1 minus n. So if I take this power, so 1 minus m to the power n is equal to qn minus qd upon q0 minus qd. After calculating, I'll get 1 minus m to the power n is equal to 0.82. Because we have calculated, this ratio will come 0.82. So this will be n. If I write 1 minus m is equal to 0.82 to the power 1 minus n, 1 by 10. So after calculating this, we will get 0.0196. So this is the migration rate, or we can say this is approximately 2%. Okay, this is approximately 2% of the genes in the black were introduced from the Caucasians after 10 generation, or in each in each generation 2% population black introduced from the Caucasians. So our donor population is what? Caucasians are donor Caucasians to black in West Africa. So Caucasians is our donor. So we can say that by 2% migration rate, they are transferred from Caucasians to black. Okay. So this type of small questions can come in the examination, that what is the ratio? This ratio 82%, 18%. I will send this full question, right? Means full question of this I'll send in the WhatsApp. You will just check it, the language of the question. You can understand that these given frequencies are of this. Okay. Now we will move to the third